When a standard large language model writes code, it acts as a stochastic mirror. It predicts the next most likely token based on a vast dataset, mimicking statistical patterns without an underlying model of computational logic. This probabilistic guessing works for an assistive chatbot. If the code is slightly flawed, a human developer spots the error, corrects it, and pastes it into their editor. But if you remove the human and give that statistical engine the authority to commit code directly to a production server, that same guessing becomes a catastrophic risk. This creates the autonomy paradox. As an artificial intelligence is granted more operational freedom to execute tasks independently, it requires significantly stricter and more formal structural constraints. To bridge the gap from a system that suggests code to one that autonomously executes it, manual human review must be entirely replaced by non-bypassable code-level invariance. Software autonomy is an engineering governance problem rather than a pure intelligence problem. On March 13, 2026, the ADAAD system mutated its own source code without any human intervention. This is the Phase 65 dashboard, the cryptographic proof of that event. The header specifically notes that there was zero human intervention in the execution path. Below the header sits the JSON execution trace. This log documents every automated decision made during the epoch. By reverse engineering this specific JSON payload, we can deconstruct exactly how the ADAAD framework governs a dark software factory, a system where code writes code. ADAAD has already achieved compounding agent lineages, moving past theoretical research into a live executing system. The autopsy begins at lines 01 through 03 of the execution trace. Here, target discovery and capability mapping lead directly to proposal generation. To generate this proposal, the system triggers a multi-agent adversarial engine. 3 agents compete. The architect prioritizes structural standards. The dream agent explores high-entropy, unconventional solutions. And the beast agent focuses on raw performance optimization. A UCB1 reinforcement learning algorithm balances exploitation against exploration. The system routes proposals through a genetic engine, pruning failed approaches using crossover mechanics and bandit selection to isolate the strongest candidate. This engine forces high-entropy exploration while prioritizing verifiable computational fitness over statistical mimicry. At line 04 of the JSON trace, the winning proposal must immediately undergo a static safety scan. This scan occurs at the governance gate. This component serves as the structural replacement for the human pull request reviewer. The governance gate enforces 23 immutable constitutional rules to evaluate the proposal. The 9 blocking rules are absolute. Single file scope confines mutations to one target file to contain the blast radius. AST validity mandates a valid abstract syntax tree, ensuring no syntactically broken code is introduced. The no-banned tokens rule serves as an essential defense against remote code execution vulnerabilities by blocking dangerous functions like exec or eval. ADAAD operates on a fail-closed safety design. If a proposed mutation fails even one blocking rule, the system triggers immediate automated containment of the epoch. Human review at the speed of autonomous mutation is a critical vulnerability. Hard-coded invariants are the only viable safety mechanism. Lines 05 and 06 detail the sandbox tournament and fitness scoring phases. These steps are part of the broader 14-step constitutional evolution loop. Inside the execution sandbox, the AI's code is isolated and tested in an ephemeral container to prevent unintended consequences. This sandbox enforces deterministic replay. If the system is fed the exact same goal and configuration, it must produce the exact same auditable outputs, with zero divergences. Testing occurs in an isolated, deterministic environment, so AI hypotheses can be proven mathematically before any system state changes occur. The final lines of the JSON trace, 07 through 10, show the final governance gate approval and the atomic patch application. The execution loop is only complete once the mutation generates cryptographic evidence of its legitimacy. Successful mutations are SHA-256 hash-chained into a tamper-proof evidence ledger. This lineage log guarantees that every governed step can be traced back to durable artifacts for external audit. For enterprise environments, autonomous systems cannot merely be functional. Their entire decision history must be immutable and auditable. This approach changes the underlying methodology of software engineering. Traditional methodology relies on the V model, where human manual coding forms the vulnerable bottom point of the V. ADAAD eliminates that bottom vertex, shifting engineering to the T model, where autonomous engines handle vertical execution. The human developer's role is not to write application logic, but to engineer the horizontal constitutional constraints. Engineering has moved beyond human-assisted AI to prioritize AI execution governed by strict human-engineered constraints. These architectural concepts have immediate enterprise applicability, as seen in the ADAAD 30-day Valuation Maximize roadmap. Commercial API deployments and continuous security sweeps demonstrate that this system is ready for production. This architecture decouples software generation value from human labor hours. Autonomy without governance is a liability. Governance without deterministic replay is an illusion. The future of engineering isn't writing the software, it's defining the unbending laws of the dark software factory.